Hi guys, welcome to lesson 10.2 on using combinations and the binomial theorem. This is probably one of the longer lessons in chapter 10. I'm going to try to get through most of the content, at least push through the content. Obviously you can rewind and review as many times as necessary, but this content is pretty confusing, and so if I take the time to go through it, it just makes the video super long. So I'm really going to try to get through the content, push through it, and if you still have questions, we can certainly go over those questions when we have an opportunity to talk again in class. So just some definitions to start with. We talked about the idea of permutations already. Permutations, the order actually mattered. So, we talked about all sorts of different activities in the previous lesson in 10.1 about permutations. And so when we talk about combinations, the order doesn't matter. It is completely irrelevant. And so that's what makes a combination significantly different than a permutation. All right? The big thing is just make sure that you understand a combination is a selection of R objects from a group of n of them where the order is not important. I'll show you the combinations notation here shortly, okay? All right, Pascal's triangle is an arrangement of values in the form of n choose R. So, well, there's a notation that we were talking about for combinations. That's the combination notation. So if I have n objects and I'm choosing R at a time, we have this triangular pattern in which each row corresponds to a value of n. So if I have 5 objects, I can choose 0, 1, 2, 3, 4, 5 of them. And so how many different ways can we do that if order is not important? So I'll show you Pascal's triangle here in the next couple of pages. All right? And then finally, the binomial theorem is a way that we can expand some binomial product. We spend a lot of time in Algebra 1 trying to teach you a plus b squared, and the pattern for that becomes a squared plus 2ab plus b squared. And then we talked about a plus b cubed, and that is a cubed plus 3a squared b plus 3ab squared plus b cubed. And then in this lesson, I'm going to show you a way that you can memorize both of those patterns by using Pascal's triangle. All right? So don't worry too much about all of this notation. This is really confusing. Basically, the binomial theorem is to allow you to expand a plus b to the n power, where n is something larger than 2 or 3 or 4. It's actually any integer value for n. Okay? All right. So let's take a look at combinations of objects chosen R at a time. The number of combinations of R objects taken from a group of n distinct objects is denoted by n choose R, where basically we're saying, look, we have n objects and we're going to choose R of them. Okay, so that's n choose R. The formula we use is n factorial over n minus r factorial times r factorial. Now this looks really confusing, but really all you're doing is you're saying, look, we have the total number of objects factorial on the top. Then I have the difference between the number and the number I'm choosing, factorial, times the number I'm choosing, factorial. All right? So let's go ahead and try a couple of examples here. All right? The first thing is we want to talk a little bit about books. Since you're picking 7 books from a stack of 32, the order of the books you choose is not important. How many different 7-book groups are possible? The number of ways to choose 7 from 32 is 32 choose 7, which becomes 32 factorial, because again, we take the total number possible. Okay, it's n factorial over n minus r factorial times r factorial. All right? So 32 factorial, and then 32 minus 7 comes out to 25 factorial, and then we're choosing 7, so 7 factorial. All right? Now, theoretically, this is 32 times 31 times 30 times 29, 28, 27, 26, 25, and then 25 and so on becomes 25 factorial. And we're putting that all over 25 factorial times 7 factorial. So we can kind of simplify that. Those are going to cancel out. So essentially it becomes 32 times 31 times 30 times blah, 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 all that over 7 factorial. All right. Now, what you certainly can do is you can plug that into your graphing calculator as 32 factorial divided by parenthesis 25 factorial times 7 factorial. And make sure that you put this parenthesis here on the bottom, because you want to multiply 25 factorial times 7 factorial first, and then do 32 factorial divided by that. Altogether, you end up with about 3,365,856 different ways that I can choose 7 books out of 32. All right, top of the next page, it says how do you know whether or not you're going to multiply or add combinations? And this is a little confusing. So the big thing is taking a look at whether or not we're talking about exactly or at most. So let's read through the scenario. It says a local movie rental store is having a special on new releases. The new releases consist of 12 comedies, 8 action, 7 drama, and 5 suspense, as well as 9 family movies. It says you want to exactly 2 comedies and 3 families. So again, we want exactly that many. How many different movie combinations can you rent? And then the second part says you can afford at most 2 movies. And that's the key word in there, is at most 2 movies. You can afford at most 2 movies, and so how many movie combinations can you rent? All right, so part A says, look, you can choose 2 of the 12 comedies and 3 of the 9 families. All right, so we want 12 choose 2 and 9 choose 3. And so we're going to take the product of those 2 combinations, because altogether we're talking about having 2 and 3 exactly. All right, so we're going to end up with 5 movies, again, 2 of the comedies and 3 of the family. But again, we're choosing a total of 5 movies. All right, so this becomes 12 factorial over 10 factorial times 2 factorial. And this one is 9 factorial, 6 factorial, 3 factorial. Okay, again, this number right here came from 12 take away 2. This number right here came from 9 take away 3. Now, 12 factorial over 10 factorial times 2 factorial, altogether that one works out to 66. And this one right here works out to 84. And altogether then that means I have 5,544 different combinations that I can choose, 2 of the comedies and 3 of the families. All right. Now, this terminology here says you can afford at most 2 movies. Okay, we can afford at most 2 movies. So that and it doesn't matter what type of movies we choose. All right. So altogether we end up with a total of 41 movies, because if I add all those new movies together, I get 41 movies. All right. Now, of those 41, we can choose 0 of them, we can choose 1 of them, or we can choose 2 of them. So 41 choose 0, and I will just tell you that 41 choose 0, there's only one way to choose 0 movies. Okay, there are 41 ways to choose 1 movie. We can pick each of the 41. And then 41 choose 2. Well, we can go through this 41 factorial over 39 factorial times 2 factorial. And altogether, that ends up being approximately 820 different combinations. And so altogether, there are 862 combinations of at least 2 movies. So you can rent 0, you can rent 1, you can rent 2. And there's 862 different ways to do that. Again, it doesn't matter what types of movies you're choosing. Of the 41, you can do 41 choose 0, 41 choose 1, or 41 choose 2. All right? Okay, so bottom of the page, there are a couple of checkpoint problems. And I promise you that I will show you the way to do those factorials in your calculator. Let's just get through a couple of examples first. I want you guys to do a few manually, and then I'll show you how to do it the easy way, okay? Go ahead, pause your video, and try these few examples for me. All right, so we're back at it here. We have 7 choose 4, so we have 7 factorial over 3 factorial times 4 factorial. And altogether, that ends up being 35. All right, this one becomes 6 factorial, because again, 6 total choices. Now, the first one is 6 take away 3, which is 3 factorial times 3 factorial. Okay, so n minus r is the same thing as r in this case, because 6 take away 3 is 3. All right, and this one comes out to 20 choices. And 12 choices, or 12 items, choose 11. Well, you know, again, you can choose 11 of them 12 different ways. There's 12 ways to do that. 12 choose 11 says that that's 12 factorial over 1 factorial times 11 factorial. All right, and 1 factorial is just 1. And so basically you have 12 factorial over 11 factorial. That's 12 times 11 times 10 times blah, 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 or 11 factorial. These cancel out. You're left with 12 over 1. All right. Okay, so let's let the cat out of the bag here. To do these on your graphing calculator, you're going to be choosing under the math menu, go over to probability. We're going to be doing a probability here. All right, and so the probability, we need to choose n objects chosen are at a time. And so the first thing you're going to do for number 1 here is you're going to do 7 math, go over to probability, and we're going to choose NCR. Okay, 7 choose 4, and it tells you there are 35 there. And that's what we got back over here And so I don't want to go through the rest of them, but that's basically how you do it. So we'll use that tool. We'll use that tool on the last one. Okay? It says, for example 2, find the number of possible movie combinations if you can choose 2 action and 2 drama. All right? So for 2 action, altogether the total number of actions is 8. Whoops, got to change my mode here. Okay, so it's 8, choose 2. All right? And we want to also choose 2 dramas. Okay, so we're choosing 2, and I have to look back to my paper. There are 7 dramas. All right, so this is 8 choose 2 times 7 choose 2. And so I'm going to go back to my graphing calculator. And again, I want 8 choose 2, so 8 math probability. I have to keep moving this, sorry. Okay, I'm doing 8 choose 2. And then I'm going to multiply that by, you know what, I should probably put parentheses around this just to make sure that these aren't going to get messed up here, okay? So there's 8 choose 2. And I'm going to multiply that by 7 choose 2. Parenthesis, 7, math, probability, option 2. And again, I'm choosing 2 action and 2 dramas. So it's 8 choose 2, 7 choose 2, take their product. And altogether you end up with 588 different combinations. All right? So that's how you're going to use your graphing calculator to do combinations. All right? Next page. Now we're going to take a look at a multi-step problem. It says a popular magazine has 11 articles. You want to read at least 2 of the articles. Now again, you got to be careful of this at least business, because this at least business says at least 2. Says you can read 2 articles, you can read 1 article, or you can read 0 articles. I'm sorry, at least 2. You'd have to read 2, 3, 4, all the way up to 11. All right, and so how many different combinations of articles can you read? Well, for each of the 11 articles, you can choose to read it or not. And so it looks like there are a total of 2 to the 11th total combinations. All right? Because again, because you're either going to choose it or you're not going to choose it for each of the 11 articles. So you get 2 choices for each of the 11. That's 2 times 2 times 2 times 2, 11 times, or 2 to the 11th total combinations. All right, so if you read at least 2 articles, then you don't read a total of I got this right here, I'm sorry. You don't read a total of 0 or 1 articles. All right? You could read 2, you could read 3, you could read 4, all the way up to 11. All right? So we've talked a little bit about this idea of the converse to a statement. All right? And so we're going to say, look, we have 2 to the 11th different choices. All right? And we're going to take away from that 11 choose 0 and 11 choose 1. All right? Because again, we're saying, look, how many different ways can I choose 0? How many different ways can I choose 1? And then subtract that from 2 to the 11th power, because that's the total number of combinations that we can read. All right, altogether, this is 2,048. And then minus 11 choose 0 is 1. 11 choose 1 is 11, and so this is 12. All right, and so this becomes 2048 minus 12, which is 2036. So there are 2,036 ways that I can read at least 2 articles. All right. Let's take a look at the checkpoint problem here. Go ahead and try this one. Pause your video, try it on your own, and we'll be right back with a solution. All right, let's take a look at this checkpoint problem here. It says you have 10 scheduled games for the season. You want to attend at least 4. So for each of the games, you can either go or not. So you have 2 choices taken 10 different ways. That's if you were to choose every single game or not, if every single game was in play, there'd be 2 to the 10th different possibilities. But we're going to eliminate those possibilities that are not at least 4. All right? So we're going to eliminate 10 choose 0. We're going to eliminate 10 choose 1. We're going to eliminate 10 choose 2. And we're going to eliminate 10 choose 3. All right? Now, if you attend at least 4, that means you attended 4 or more. So 10 choose 0. 10 choose 0 is 1 way. 10 choose 1 is 10. All right. 10 choose 2. Well, we're going to need our calculator again. So 10 choose 2. If I go back on here and go 10 math, go down to option and CR, I'm going to choose 2 of them. So there are 45 different ways I can choose 2. So this is 45. And then finally, to choose 3, how many different ways are there to choose 3? Well, that's 10, choose 3. And there's 120 different ways I can choose 3. All right? So 1 plus 10 plus 45 plus 120. Let's get that number all together. Actually, let's just do it this way. Let's go 2 to the 10th power, and then minus 1 plus 10 plus 45 plus 120. And then that tells us that there are 848 different ways that you can choose to attend those games. All right. Okay, now Pascal's triangle. You guys see how I keep going back and I have to use my calculator to do all of these. When you have smaller numbers, it's a heck of a lot easier if you use Pascal's triangle. Now, Pascal's triangle is a triangle that's created from looking at the various combinations of n objects. It says the first and last number of each row are always a 1. Every other number other than 1 is the sum of the closest two numbers in the row directly above it. Okay, so if in row 0, this is row 0, the 0th row, all right? I have 0 objects and I choose 0 of them, all right? I have in row 1, and I know it looks like the second row, but it's not really the second row, it's row 1 because we're calling the first one row 0. In row 1, we have one object chosen 0, so I have 1 choose 0 and 1 choose 1. So if I have one object, I can choose it or not, all right? In this case, we have in row 2, we have 2 objects. We can choose none, we can choose 1, or we can choose both. In the third row, we can choose 0, we can choose 1, we can choose 2, or we can choose 3. All right? And so what do those numbers look like? Well, if I have 0 objects and I choose 0, there's only one way to do that. If I have 1 object and I choose 0 of them, I can do that one way, and I can choose that one way. 2 objects chosen 0, that's 1, 2, 1, and 1, 3, 3, and 1. Now, as we set up here, each number is the sum of the closest two numbers above it. So you'll see that for the 3 here, it's 1 plus 2 gives me 3. And in this case, this is 1 plus 1 gives me 2. 1 plus 2 gives me 3. 2 plus 1 gives me 3. And we have 1s on the end. So you might imagine that the 4th row, we'd bring another 1 down here. And then this would be 1 plus 3, which is 4. 3 plus 3, which is 6. 3 plus 1, which is 4. And then a 1 on the end. These represent 4, choose 0. 4, choose 1. 4, choose 2. 4, choose 3. And 4, choose 4. So let's actually use this. All right? It says out of 5 finalists, your class must choose 3 class representatives. Use Pascal's triangle to find the number of combinations of 3 students that can be chosen as representatives. I don't want to take the time to go ahead and, again, I want to choose 5. I want to do 5, choose 3. I don't want to plug this in my graphing calculator. Maybe I forgot it. And again, you guys get it. You can certainly plug this into the calculator. You could do 5 factorial over 2 factorial times 3 factorial and get the same thing. But instead, let's use those entries in Pascal's triangle. Pascal's triangle, this is 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, and 1. And again, remember, I'm just getting these numbers by adding the 2 numbers above it. Whoops. All right? And so this would be the 5th row. All right? If I went with, if I take a look at those coefficients, then that's 1, 5, 10, 10, 5, and 1. Now, if I have 5 objects and I choose 0 of them, there's one way to do that. If I have 5 objects and choose 1, there's 5 ways to do that. If I have 5 objects and choose 2, there's 10 ways to do that. And 5 objects choose 3, 10 ways, 4, 5 ways, and all 5. There's only one way to pick all 5. All right. The value of 5 choose 3 is the 4th row. I'm sorry, the 4th value in the column. So 1, 2, 3, 4. That is 5 choose 3. All right. And therefore, 5 choose 3 is equal to 10. There are 10 different ways that we can choose 3 elected officials out of 5. All right. Okay, so let's take a look at the checkpoint here. It says use Pascal's triangle to find the number of combinations of 3 students that can be chosen from 8 finalists. Okay, go ahead and make Pascal's triangle. You can extend the one up above if you need to get down to row number 8. So let's go ahead and do that, and then we'll take a look at 8 choose 3. Okay, this is 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, and 1, 1, 5, 10, 10, 5, and 1, 1, 6, 15, 20, 15, 6, and 1. I'm running out of room on the right side here. 1, 7, 21, 35. And again, please remember that all I'm doing is adding these numbers to get these. And there's a 1 down here on the end. I know it's not really triangular, but I only need one more row because I have to get to row 8. So 1, 8, 28. This would be 56. This would be 70, 56, and so on. But I really don't care about that because I want 8 choose 3. So it's that would be 8 choose 0. This would be 8 choose 1. This would be 8 choose 2. And so right there is 8 choose 3. So there are 56 different ways to do that. And we can do that with Pascal's triangle and never have to actually use our graphing calculator. Is it a bad idea to check? No, not really. We'll go 8, math, change this to NCR, and there are 56 ways to choose 8 objects, which is what we came up with. Okay? All right, so that's kind of how everything kind of ties together. Now let's take a look at this idea of the binomial theorem. This is the part from the first lesson, or the first part of the lesson I said, listen, let's not worry about this right now. This is a really cumbersome idea, but really it's not too bad. What we do is we take the coefficients from Pascal's triangle, and so if I want to do a plus b to the n power, so this is x plus 3 to the 7th, x plus 5 to the 4th, those types of things. Whatever n is, whatever that power is, the coefficients of each term become the entries in Pascal's triangle. All right, so n choose 0, n choose 1, n choose 2, n choose 3, etc., all the way up to n choose n. Now I want you to take a look at the powers of a. I'm going to pick a different color here. Take a look at the powers of this first term. This first term, we take a to whatever my power is, and then a to the n minus 1, and then a to the n minus 2, n minus 3, all the way down until we get to a to the 0. So my powers of a go to 0. So we start at n and we go to 0. All right. My powers on b, you'll see this is b to the n. My powers on b start at 0 and then go to the first and the second and the third and so on all the way up to n. So my powers of b start at 0 and go to n. Every time a goes up by 1 or down by 1, b goes up by 1. All right. It says notice that each term of the expansion of a plus b to the n has this exact same form, which is n choose r times a to the n minus r times b to the r. Now, all this is saying is we're saying, look, it's n choose r, so if I want that term, each term is in the form n choose r, and then a to the n minus r, and then b to the r. So again, we take the highest power of n and we reduce that. Every time we bring r down by 1, I'm sorry, increase r by 1, we bring this one up by 1. So we're bringing the power of a down, but we're bringing the power of b up. All right, so a little bit confusing. Let's take a look at an example here, and let's see how this works for you. All right, let's expand x plus 4 to the third. So to do the third power of this, we need the third row of Pascal's triangle. Now, remember, this is not the third row. This one's the third row, because this is row 0, row 1, row 2, and this is row 3. So those are going to be my coefficients. So my coefficients are 1, 3, 3, and 1. All right? Now, this is my A, this is my B. All right? I'm going to do these in different colors, so maybe let's clean that back out of there. All right? And again, the reason we're choosing the third row of Pascal's triangle is because we're dealing with a plus 4 to the third power. All right? Okay, so this is my A, and so I'm going to take that A and I'm going to go x to the third, x to the second, x to the first, and x to the 0. All right? Now, let's take a look at the B. This is my B. That becomes 4 to the 0, 4 to the first, 4 to the second, and 4 to the third. All right, now, since this is plus, these are all going to end up being pluses, so we'll just put pluses in there for now. And let's go back to a nice solid black here so we can finish up. X to the third, 4 to the 0. Well, 4 to the 0 is just 1, so this is simply x to the third power. All right, here, this is 4 to the first power, which is 4. 3 times 4 is 12, x squared. 4 to the second power is 16, and 16 times 3 is 48, x to the first power. All right, and then finally on the end, there is 1 x to the 0. Well, x to the 0 is just 1, and 4 to the third power is 64. All right, so that's what you're looking at. Okay, that is the expansion of x plus 4 to the third power. All right, now let's try one of these ones. It says expand the power of a binomial difference. Well, now it's an 2m minus n to the fourth power. All right, and so what we're really going to do is we're going to make this plus a negative. So let's make that negative n. All right, we want the fourth row of Pascal's triangle. So 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. And man, maybe it would be a really good idea to write Pascal's triangle, maybe the first 4 or 5 rows, somewhere in a planner or someplace in your notes so you've always got it. So we don't have to keep recreating this all the time. So my coefficients are 1, 4, 6, 4, and 1. All right, and so this is 1, 4, 6, 4, and 1. I'm going to try to slide that over there. All right. Now let's pick a different color for the first term. The first term is 2m. All right. Now the powers on the first have to go from 4 all the way down. So this is 2m to the fourth power, 2m to the third power, 2m to the second power, 2m to the first, and 2m to the 0. All right. Now let's take a look at our negative n. Our negative n has to be raised to those powers, but going up. So this is negative n to the 0 power, negative n to the first power, negative n to the second power, negative n to the third, and negative n to the fourth. Now you might be wondering what signs are supposed to go in here. Theoretically, there's a plus sign in between every one of these terms. All right? But I know that when I raise a negative number to an odd power, I'm going to get something negative here. All right? So I have to go 2 to the fourth, m to the fourth. So 2 to the fourth is 16, and then m to the fourth. And then negative n to the 0 power is just 1. So my first term is simply 16m to the fourth power. All right? Now my second term. My second term is a little bit more challenging because now what you have here is you have 2 to the third and m to the third. So 2 to the third is 8. And then 8 times 4 is 32. You have m to the third. And now you have negative n to the first power. Well, n to the first power is n. And a negative n to the first power becomes a negative. So that makes that whole term negative. All right? Let's take a look at the next one. Go ahead and square and square. So this becomes 4. Okay, 6 times 4 is 24. We have m squared and negative n squared. Well, m squared is easy. Negative n squared just becomes positive n squared, and so that's plus. Okay, now let's take a look at the next one. This is 2m to the first power. Well, 2 to the first is 2, and 2 times 4 is 8. M to the first, I'm not going to put the 1 up there. And then this is an n to the third power. Now keep in mind this was negative n to the third, and so I made a small mistake here. This has got to be a minus sign here instead. Okay, it's negative n to the third power. And then finally on the last term, this becomes 2m to the 0, which just goes away. And then negative n to the fourth power is simply n to the fourth. Now I want you to take a look at the signs. The leading one will always be positive. No matter what, the leading one will be positive as long as this is positive. All right? Now when it's a subtraction sign here, it goes plus, minus, plus, minus, plus. Because we're taking even powers of n, taking odd power, even power, odd power, even power. So every time you're taking an even power, you're going to get a plus sign. Every time you're taking an odd power, you're going to get a minus. All right? And so that's the gist of it. That's the whole kit and caboodle on that idea of using binomial expansion. Okay? Now, this is a little bit tricky. It says, find the coefficient of x to the fifth in the expansion of 2x minus 7 to the ninth power. Well, remember that each term of 9 choose r, 2 to the x, each term has a form 9 choose r, whatever r is, and then 2x to the 9 minus r power, negative 7 to the r power. Because again, each term we're going to start at 9 and we're going to keep decreasing. Every time I increase r by 1, the power on x goes smaller. And then as r goes up, I continue to increase the power on the second term. All right? So if I want the fifth power, of x, that's going to occur when r is equal to 4, because 9 minus 4 is equal to 5. All right? So that means I want 9 choose 4 times 2x to the 9 minus 4, which is 5. Make sure that's in parentheses. Times negative 7 to the fourth power. All right? Now, 9 choose 4. 9 choose 4. You can do Pascal's triangle if you want to, but if you have 9 items, you have to continue working. I had Pascal's triangle up above up to row 8. 9 choose 4 ends up being 126. I'm not going to take the time to do the rest of Pascal's triangle right now. This is 2 to the fifth, x to the fifth. So that's 32, x to the fifth. And then finally, negative 7 to the fourth power. Negative 7 to the fourth power is positive 2,401. Now, We got the x to the fifth here over on the side. Multiply all the constants together. 126 times 32 times 2401 comes out to 9,680,832. And so obviously that number is the coefficient of the x to the fifth term. So that's a little bit tricky, but that's the idea. Okay? All right, you got a checkpoint problem like it. Let's try those few checkpoint problems, 7, 8, and 9, and we'll be right back with solutions. All right, I'm just going to run through the solutions on these ones. We will take the time to do number 9. But for number 7, you should have a to the third plus 6a squared b plus 12ab squared plus 8b cubed. All right. For this one, because it's plus or minus now, notice that they put the 6 in front of the s, so that saves some trouble here. The first term ends up being 1296, 1296 minus 864s plus 216s squared. Minus 24s to the third and plus s to the fourth. And again, if you want help on how to do that one, we'll talk about that one more in class. Okay? So if I want x to the 8th power, that's when r is equal to 2. All right? And so this becomes, we have 10 choose 2 times 3x, and we're going to raise that to the 10 minus 2, which is the 8th power. All right? And then we've got the negative 2 being raised to the 2nd power. Notice the sum of these two is 10, which is what I want. So this becomes 10 choose 2, and this is 3 to the 8th, x to the 8th. All right? So it is whatever 10 choose 2 times 3 to the 8th times negative 2 squared. And then I'm just going to put the x to the 8th on the end. All right? So we need to get this calculation. 10 choose 2, 3 to the 8th, and I know this is kind of messy, but this says negative 2 squared. All right? So let's plug all that into our graphing calculator. Again, you can use Pascal's triangle if you want to. I'm just going to skip that and use my calculator. All right? So I wanted 10 choose 2. I want to multiply that by 3 to the 8th power. I'm going to multiply that by negative 2 squared. Well, negative 2 squared is just 4. All right, and so I get 1,180,980. And so that is 1,180,980 x to the 8th. Okay, and again, we'll spend some more time going over that, but that is the gist of lesson 10.2.